Thanks for the introduction, madam. Thanks ARC for conducting this session, giving us the opportunity to share Factory of the Future as a concept. We have very good first half session. Lot of technical know-how has been already been shared in terms of what is happening in the automation as a space. My attempt would be to thread all these pieces together to create plant of the future. Second important aspect is the usage of technology, which is IT in plants. And IT is becoming more and more important to remain competitive in the marketplace. Technology adaptation in the plants in all this. I'm just sharing some statistics with you. India, many reports talk about how we are increasing our innovation in the domains like biotech, pharmaceutical, auto tier 1 manufacturing, even in assembly operations. The norms of the industry is changing because most of these organizations are getting into global context also. Operational excellence is not becoming extremely important. It is no more a fancy feature for the manufacturers. It is becoming, norm of the industry. There is also a survey note from Global Manufacturing Competitiveness Index, which talks about the manufacturing competitiveness with various countries. India today stands fourth, and in the next 5 years, there is a projection that India will move to the second position in all this. There are many factors which influence manufacturing competitiveness. There are internal factors, external factors, but the most important factor which I want to highlight where we lag very badly vis-a-vis our other countries is the physical infrastructure. This physical infrastructure has got more than 20 different elements, but among top 4 is IT and telecom. Apart from availability of good quality of electricity and other infrastructure needs. The whole attempt of this session is to see how IT can make the difference. But before we enter into this, technology, just have a look on the technology which is emerging in typical plants. I remember where people goes to plant, goes to the equipment, take the analog reading, note it down on a piece of paper. Today, some of our potential customers are demanding that I can see sitting here visualization of that information. So it's a sea change. I myself has commissioned plants using Mimics and the control board. Today we are talking about ability to control something sitting remotely. There are many changes with the information which plant generates. Traditionally, people were talking about information used for generating reports. We are talking about how these reports can be converted into dashboards. And if the dashboards can do some prediction associated with assets and all. So many previous speakers have covered these points. So important is technology in manufacturing, in plants, is continuously changing and it's improving. It's the matter of adaptation of these technologies and how you want to see business imperatives are met. A typical manufacturer, even the executive management, are looking for tremendous pressures when it comes to manufacturing environment. The compliance, energy efficiencies are definitely there. Because of globalization issues, plants are under pressure to bring visibility to decision making. Because these plants are in middle of the whole supply chain processes, and the make process makes it very critical. If I'm not strong in that piece, the business is not that good. Cost pressure is always there for manufacturing facilities, for plants, and the prime reason is 1% improvement you do, it directly hits the bottom line of your balance sheet. So it becomes an obvious choice for CFOs, CIOs, and CXOs to look, how best we can improve on this. Innovation is one more important aspect, and this innovation is with respect to your products. which you are introducing in market. It can be next generation technology, or it can be disruptive technology. But you can design a single unit which can be special, but making it commercially available, and in a global context, making it available across geographies is a challenge. We see, I can give you a very simple example. P&G makes these diapers. If one change in the diaper specification takes 4 months to launch it globally, by the time the whole market is gone. So the whole new product introduction and keeping the differentiation in marketplace is important. And it is only possible when plants are enabled to a next level. Continuous improvement, the investments which you have made on assets, return on those, improving inventory turns are another critical factors which keeps getting monitored by the management people. Now, how we are going to achieve this? We are introducing a word, we need smart manufacturing, or we need smart plants for all this. This is a typical diagram of an integrated enterprise. And let's see what are those attributes which we are discussing since morning. I'm just summarizing those through this. A good manufacturing facility is tightly integrated with their business systems, and they are adaptive in nature because demand is not constant. Gone are those days where you produce, you stock, and you have a sellable market for all this. So you need to see that how plants can adopt the demand changes and vice versa. If there is a downtime in your assets in the plants, how it can be, how the information can impact your order fulfillment process in supply chain. Today, everybody is talking, the well-connected plants. And in order to have effective energy management, plants should be connected within the own plant facilities to their suppliers, so that any change you make in the plant is in conjunction with the supplies which you are supposed to get from your supplier communities. And in the whole process, what you are trying to achieve is you are reducing your inventory, which is indirectly related to your cash flow cycles. Today, if I don't talk about energy and waste, I can't say smartness is there. So every manufacturing or smart manufacturer today thinks, because of high energy cost and the penalties associated with waste, how effectively I can do energy management and waste management systems. From a customer perspective, customers are more demanding. They are looking for their unique specs to be met. So you are reducing your lot size. There is a dream that one unit become a lot size. I don't know when it will be true, but it's important that you make such flexible systems or use those technologies which helps you for quick changeovers so that you are closer to the customer need. Another big aspect is customers are demanding a lot of traceability across the value chain if there is an issue with the product. Today you might have heard of these callbacks which Toyota is making, or there is a drug issue with Ranbaxy. If they are smarter, they will be able to pinpoint the exact batch on which the correction or what went wrong to that particular batch. Now this is not easy, and it's only possible when the plant from inside is smart. We are talking about all these peripheral systems where it needs to interface, but the foundation, which is plant itself, should be intelligent. And it's all not easy to make plant intelligent. So my colleagues were talking about complete integrated engineering of plants all the way to controllers. The reality is, within a single plant, you have maybe 4 or 5 types of controllers. Because plant uses different processes and there are inherited benefits of certain technologies which are better, and maybe you are buying some equipment in your plant which already has a tie-up with some X company, you finally land up in multiple controllers at the plant floor environment. Today, a lot of discussion happened on the sensors which are actually sensing the devices or which are the instrumentation sensors. they are enriching more and more embedded technologies going into these sensors, and there is a pressure on the plant networks to transmit more data. I have worked on LMLD controllers where we used to have data highway plus proprietary network. I think 57.6 kilobyte baud rate. Today we are 128 with all the new devices coming in from the control network. But the ability of the instrument to transmit now is much more than what it used to be in past. And these networks are not possible to give you that benefit. Of course, there is an advantage of using traditional networks because a lot of automation vendors says that they are deterministic in nature. I cannot guarantee the performance of the controller. And there was some discussion in the morning with one of the speakers from ONGC, talks about that this monitor only runs with this. There is a demand from the customer community to be open and, ensuring that deterministic behavior remains as it is. If I ensure that, I think the supplier community here should not have any problem. And many organizations, including Cisco, including G, and maybe definitely others also, have come up with a new industrial Ethernet or Internet of Things or Internet IP kind of concepts, where certain bandwidth is ensured to keep the data deterministic in nature, and rest is all used for other purposes. Second important thing is plant don't have ERPs, like a single Oracle or an SAP. So finally you land up with multiple applications. Some application doing production management, some application doing asset management, some application are doing quality management systems. They are all referring to the same asset in a different form, in a different context, and they also don't talk to each other. So there is a second level of need to make plant applications communicate to each other by using, say, architectures like service-oriented architecture, where you can manage the master data information of the plants, of the plant equipments. So finally, you land up in a situation where you have end-to-end data. Now, since morning we are talking about data, but we are talking only the data which is generated by sensors and the controllers. What about those data which is generated by my CCTV camera which is installed on a kiln outlet? What about those image processing systems which is generating, the movement of the paper when I am actually winding it? So there is a lot of unstructured information also which exists in plants. And I will cover that in my big data discussion, that how that additional information can be used. Now with networks like this, there was a discussion on remote monitoring. Now with networks like this, on the same network, I can transmit data, I can transmit images, I can transmit voice. So it's not only the trends which you are going to see in a remote location. You can actually, a web camera can be focused on the crack of the asset. You can actually monitor it sitting 200 kilometers away. And you can pick up your phone and actually talk on the same network to talk to that guy. So today, futuristic plants are talking, these kind of enhanced by using technologies which are well established in business systems. So you will have convert systems for many, many years now from companies like Cisco. The second important aspect is connecting plants to the peripheral systems. And it's a mammoth, very difficult task to ensure, because the behavior of plant data is very different from the business systems. But this information, as I said, is important to be more agile, to be more closer to customers, to be more adaptive when it comes to flexibility. And last but not the least is the data which is generated by the plants. Now this data needs to translate, or this data needs to translate into information. This information needs to translate into knowledge, and this knowledge needs to translate into wisdom. Now, how I will generate the wisdom and how I will convert all this data is by putting the data into a context. Now, once the data is context, and this is what we are traditionally doing, generating MIS reports, reporting what went wrong, reporting it back to the management. It takes 30 days, maybe 2 months to collect all this and you generate. With the foundation which we discussed in Smart Manufacturing 1.0, we can actually enable it very fast. This information needs to club with the business system information to do lot of analysis of this information, which can be finally converted into dashboards and KPI monitorings. Visualization can be role-based, so you can access the data as per your security, as per your profiling. A VP of an operation wants to see data in a very different context than an operator. So all those things can be managed if the structure is, if the foundation is like this. And the most important, which the previous speaker has also talked about, is the ability to do predictive analytics. Mr. Andy and other people have talked about, can I run the plant with the past data? Can I simulate those mimic operations and do predictive analytics about the possible failure of an asset, which is a direct loss, it's a waste and direct loss to my capacity, or it can be in conjunction with the quality. Again, it's a waste because any defect or rework which you want to do or will impact your throughputs or the efficiencies. And it can also be related with your energy, the energy patterns and the ability to predict that this will go and improve further. So we are talking about analytics using not only the information from the historian or PLC, but also other data sources. There is a session tomorrow in detail. I'm not going to talk much on the new concept which is emerging, which is from machine-to-machine connectivity, propagated by almost every country, whether it is Singapore, whether it is Germany, Europe, America, and everybody is talking about Internet of Things. Just as a very small introduction, because there is a very detailed session tomorrow, the world is world is treating everything as sensors. This bottle might have a sensor, your phone has a sensor, your asset has a sensor, even a BP machine will have a sensor, a CT scan can sensor. And all this is happening because a lot of embedded technology is going into this. Today, if you take an example of a car, I think it has more electronics than steel. And it can transmit a lot of data. Now, this data is unused unless until you use this information for effective, of course, for the monitoring purpose, as well as for the diagnostics purpose, and maybe for the predictive analytics purpose. We are talking about smart products, a product which can transmit this information, a smart plant which can produce this smart product, and the services which can be enabled, which can be remote monitoring and diagnostic kind of services, which can be built on top of it. Think of a BHEL turbine installed at NTPC location, and turbine has the intelligence to transmit data from an NTPC facility. And the people can do analysis which can lead, giving it the information back to NTPC that these are not the engineering parameters on which I have decided this turbine. So you better increase this pressure or increase this temperature. Or can do the analysis for the improvement of the design of the turbine itself. So this is all possible today because technology is helping, or Internet of Things is helping you to do and achieve all this. Now there is a fusion and lot many jargons, and this is maybe a slight constraint. My colleagues have put in these numbers and I can fill it with so many other information also. There is a fusion. It's RFID, 3D tagging, 3D SCADA systems, energy management, smart grids, virtual plants, virtual digital manufacturing facilities and all. These are all technology fusion which people are adopting for operational excellence and for innovation needs. Very good example is the digital manufacturing, where today you are not setting up the plant and on an Excel sheet trying to do balancing of two different lines, identifying the capacity constraints, but you are actually building the whole prototype of the plant itself. And it is no, why only the plant? I can actually take the whole supply chain network. I can actually take your numbers of your growth pattern, which you have projected or your CEO wants to project, and see and simulate all those situations upfront, telling you that this is possible, this is not possible, this layout is good, bad, you need more space, taking captive or OPEX decision on whether you should do it now or you should do it later. So technology is changing all this. It has changed the product space. Today, manufacturers like Toyota don't want to crash a physical car to tell you what is the data. They can actually simulate with all this. We are talking all these technologies coming all the way down to plants where you can simulate material flow, you can simulate, and in future, who knows, there will be the chemical models available to know the behavior of a boiler, or with the data you can actually simulate and develop all this. From out of this, many things have been talked about, and I'm just covering very few of them. There can be a very big list of all this. We definitely see smart devices and the mobility impacting the plant floor. You can think of view anywhere, operate anywhere. It is possible. We are deploying these solutions as TCS with some of our customers. Remote monitoring and diagnostics, there was a discussion which is read-only. That is very much possible. We are today in our own office monitoring all the chillers at TCS buildings at Pune facility in a cloud environment. I can tell you exactly in every minute what happened to that chiller. And another most important thing where on the entire focus is going is predictive analytics. And why predictive analytics? It's because we are not in that world where we want to postmortem things and then improve. We want upfront, because data is there, upfront know what is going to went, what is going wrong in future. And here, these analytics don't restrict your thought process only to time and series data, or just the sensor data of the PLCs and controllers. You can build this with unstructured information, and you can use traditional models, statistical models, and all other models. You can also use big data techniques to do this analytics and model building, which will reduce your resource requirements. And it also allows you to manage variety of information, which can be time series, which can be RDBMS data, which can be unstructured information. Big data is actually changing all those aspects. Now, what we discussed, there has to be direct business value to all this. You are not going to adopt smart manufacturing or smart plants. Just somebody is telling you to do all this. These are some of the numbers, and of course we have written and just captured the essence of it, where such adaptation in global customers, where they have adopted, have realized the kind of business benefits. Definitely it impacts your inventory turns. You are able to do a lot of effective asset utilization and quality management, which directly correlates into your throughput numbers, which indirectly correlates into your inventory turn ratios. Return on asset, which is again a balance sheet information which you publish. It improves because the throughput of the plant has been increased. A decision to source or to manufacture this good in plant A or in plant B can also be very effective in this scenario, because plants are able to generate visibility, and people have improved on their order fulfillment cycles by adaptation of intelligent plants. And of course, if these systems are deployed, and you might, if you are in a multi-plant environment, you always feel that with the same asset, with the same raw material quality, One is reporting a 80% efficiency, other is reporting 85%. So they must be doing something different which is generating, which makes them more effective. And these systems allow you to do those benchmarkings across plants. And not only the benchmarking, generating the good practices out of it, which can further improve other parameters, which can other plants can actually adopt those good practices out of it. This is the saying of one of the scholar, and this is, I don't know in which year this will be realized, but they say that plant will be so highly automated that there will be only two physical employees will be there. One is the dog and one is the man. Man is going to feed the dog, and dog is going to keep the man away from touching the equipments. So that's the kind of dream global manufacturers are going with. Now, of course, it's a transformational journey. It's not simple, and you need to take baby steps to get and realize the benefits. These are multi-million, multi-year programs, which gives you delta incremental benefits. But you need to carry a bigger vision, what you are actually trying to achieve. And this is the stepped approach, and on the same approach, we have built the comprehensive framework to help our customers achieving these objectives. Plant is the foundation, is the place where the data is authored, and it needs to adopt different systems for its own benefit. And then you require the manufacturing operation transformation, connecting systems together. The people change management, the way they are actually running these plants to next level, and maybe technology also plays a major role. And once you have the data, you can actually visualize the data in multiple contexts. You can think data as just as an information to start with. And gradually, you can actually look the data in an integrated environment, and then you can make the data intelligent, which is nothing but your predictive analytics. This is some of the representation which we think it can vary from customer to customer, domain to domain. So it is very generic representation. We, in order to address all this, have built many internal assets with our research team in Pune, TRDDC. And they have their own algorithms, and they are helping us in building those models. There are certain assets which are reusable to give you that jump start in taking this transformational journey. And we also collaborate with our strategic partners like Cisco and all, which helps you in migrating to the plant infrastructure what you have today to the next level. There are many adaptation of new technologies are coming for plant engineering also. Smart plant is one. There is a presentation tomorrow from Siemens. They also have a parallel tool. And these tools helps you what in the morning session we discussed, allows you to do all the mechanical, electrical, P&ID, and maybe control system engineering all put together. So whole product lifecycle management for the plants can be managed. Now it's a stepped approach. It cannot be taken as a big bang like a transaction system. It cannot be forced also from like the way SAP is forced by CFOs. What the logical steps what we can think of is that we need to do an assessment of where we stand today vis-a-vis our vision, generate a heat report, identify what are those critical for business and where the gaps are high, and actually prioritize short-term and long-term objectives based on your business objectives, and then create a phased manner roadmap of achieving this. That ends my presentation. Thank you very much.